new lecture. Today,
I will teach.
class 8, chapter 7, set. Topic is set. So we have to know what's called set. Who invented set? You can see here is pen. It's a set of pen. Set of, we all know the dinner set, we all know cup set, we all know set of table, set of chair. So what is called set? A set is the well-defined objects or collection. Okay. So who invented set? German mathematician George Cantor invented set. Okay. Let's come back. So a set is simply a well-organized objects of real imaginary world. Or another definition, a collection of some well-defined objects is called a set. Is called a set. I think this is better. A collection of some well-defined object is called a set. German mathematician George Cantor, 1845 to 1918, first introduced the notation of set. A set of books, set of pens. So, who invented set? German mathematician George Cantor invented set. Okay, let's come back. Is object is called an element. Is object is called an element. And for set, you have to use every element. You have to keep it in a second bracket. You have to keep it in a second bracket. Okay, and set always expressed by the English capital letter of English a the capital letter of English alphabet A B C, this type of thing. Okay, the set is expressed by the symbol of second bracket. So we have learned the definition of set. Now we will have to know some notation in this chapter. Okay, so let's come back to the board. We have learned the definition of set and who invented set. And we all know German mathematician George Cantor invented set. Okay, let's come back. We have to know this is universal set, union of set, intersection of set, subset, and complement of set A. This is belongs to, this is not belongs to, this is empty set. And we will learn today universal set, union, intersection, complement, and finite set and infinite set. So I'll try to complete this exercise between two lectures. This is today I'll teach you the first lecture only related to universal set, intersection, union, and complement related maths. And lecture 2 I discuss set builder methods and Venn diagram also. So let's start. How many methods of set? Okay, let's come back to the board. Now we will have to know about definition of elements. So please come back. Elements, the objects or things, things that make up a set are called its elements. You can see A equal A comma B comma C. Here A, B, C are the elements of set A. Now representation of set and methods of expressing set. There are only two methods. You can say first one is a tabular method or roster method, and second one set builder method. Please come back. First one is tabular method or roster method. A equal 5, 6, 7. Tabular, that means made by table, using table 1, 2, 3. B equal 3, 4, 5. C equal 5, 6, 7. These are the table. Okay, so you can see visible. All elements are visible and made by table, using table. So here is a equal 5 comma 6 comma 7. Then number 2 is set builder method. So please come back, set builder method. Example, b equal to, set b equal to x such that x is a factors of 12. Factors of 12. That means set builder method, set builder method, build by something. So here is a equal 5 6 7 is clearly given, but here is you have to break 12 at first, then we will get set b. This is the set builder method. So tabular method, always you can see the visible by table, using table, but in set builder method you can see this type of symbol, 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 and this type of symbol. Okay, you can see various types of symbol you have to break, then we will get the set builder method. So we will learn now universal set, then complement of set, universal set, complement of set, union of set, intersection of set. Okay, so if you want to learn set, about chapter 7, so you have to follow 2 lecture. When I start this chapter, I create to divide this chapter into 2 lectures. First one is intersection and union and complement. Then second one, I will discuss using set builders method, some using Venn diagram. Okay, so we will discuss today lecture 1. So if you want to know the chapter chronologically, you have to be careful about various types of notation of set and instruction. Okay, so let's come back again. We'll discuss the universal set. Now, universal set. What is called universal set? That means we have to know the universal set. Universal set, that means in mathematics, all sets under discussion are subjects of a fixed set. In this content, the fixed set is called the universal set of all sets. The universal set are denoted by this. This is for the universal set. If we observe the figure, we can easily got the universal set. That means all, everything is a universe. Here is, you can see, here is the set A and set B. Now you can see that here is one circle, here is another circle. This part is 1, this part is 2, this part is 3, this part is 3. So this set name is A, this is B, and here is 1 2 3. So another portion will be 4. And universal set, same way I have drawn this. Now universal set equal to, here is 1 2 3 and 4, 1 2 3 and 4. Here is 4 elements. Now a set equal to, we can see here is a 1 and 2, here is 1 and 2, and set b equal to 2 and 3, set b equal to 2 and 3. Now we will have to know the union of sets and intersection of sets, and we have to know the complement of set and various types of notations and symbols used in this chapter, that means set related. Okay, let's come back to the board. Now we will learn union of sets. Already we have learned universal sets. Now we will learn union of sets. That means for function of union of set, common and uncommon all. Union, that means you can see this U, that means Sometimes we can say cup, but actually this is a union of sets. That you can say union of sets, the set consisting of elements of two or more sets, are said to be union of sets. Let A and B are two sets. A and B are two sets. We'll write A union B. The set consisting of elements of two or more sets are said to be union of sets. If A and B are two sets, then we can write A union of B. Let's come to the board. Example, here is A equal to 1 to 3, B equal to 3 4. Then determine A union B. At first you have to write given. If you can see this type of maths, at first you have to write given. Given here is A equal to 1 to 3, B equal 3 4. Then A union B. Element of A and union element of B. So union, that means common and uncommon. So let's come back. Here is 1 2 3. Here is common is only 3. We have to write common and uncommon. So here is uncommon is 1 2 and common is only 3 and uncommon is 4. So we have got union. Okay, we have got union. Now we will have to know the intersection, then we will learn the complement of sets. We have learned union of sets. Now we will have to know intersection of sets. This is the important part of this exercise. In this exercise related to union, intersection and complement. Okay, in this chapter related to union, intersection and complement. So we will have to know intersection of set. So please come back to the board. Intersection of set, the set consisting common elements of two or more sets is known as intersection. As set. Two or more sets, just common element. Just you have to find out common element. It's the intersection. That means sometimes we can say it's a cap. Okay. Union. This is cup or union of set. We can say cup, and intersection of set we can say cap, but it is intersection of set. Intersection, that means you have to take only common. So let's come back. You can see here is A equal 5 6 7, B equal 4 2 4 6. You have to find out A intersection of B. So in this type of maths, you have to write a given part. Here is A equal 5 6 7, B equal 2 4 6. You have to write A. Then intersection, then you have to write B. Intersection means common. This is the intersection. So here is common is only 6. You can see here is common is only 6. This is the answer. So we have learned union and intersection. Just now we have learned intersection. Okay. Now we have to know the finite set, infinite set, and we have to know the complement of set. Okay. So let's come back to the. We have to know the finite set. Elements are fixed. That's the finite. And elements are not fixed, that is infinite. So please come back to board. We will have to know the finite set and infinite set. Finite set. A equal 1, comma 2, comma 3, dot dot up to 10. Here is elements are fixed. The sets whose elements are fixed, that's the finite set, and elements are not fixed, that's the infinite set. And empty set which has no elements is called empty set. Please follow the board. You can say finite set 1, 2, 3, dot dot up to 10. Here is element is fixed for this. This is finite set. And infinite set, here is b equal 1, 2, 3, 4. Here is, it has no elements. Element is not fixed. Okay, element is not fixed. For this, here is 10, but here is no 10. Element is not fixed. So we can say this is the infinite set. I think you have got it. Now, empty set. The set which has no elements, the set which has no elements is called an empty set. And empty set expressed by this symbol or this symbol. Be careful. Empty set. So A equal, this is empty set. It has no elements. For this reason, this is empty set. Now we will have to do some maths. So please come back to the board. We will solve some maths. Now follow the board. You can say here is some maths union and intersection related. Union and intersection related. We know union means common and uncommon both, and intersection only common. So please come back and you can see here is A equal to 1, 2, 3, B equal 2, comma A, and C equal A, comma B. We have to determine this is number 1 and this is number 2. So at first you have to write the given of this. If you can see this type of maths, you have to write given. Okay, so you can see I have written here is A and here is B and here is C. But here is, you can see we have to find out A intersection of B union of C. B union of C. Here is two parts of this maths. Here is how many parts? You can see here is two parts. You can do the maths two parts at a stress, or but for your betterment you can do the maths in two steps. Now follow. I have written at first B union of C. B equal to comma A union A comma B. So at first we will have to do B union of C. We will do B union of C. So union means common and uncommon. For this reason, here is common is only to A. Common is only A. So we get 2 comma A comma B. So we have got B union of C. Now we have to find out A intersection B union of C. A intersection B union of C. So what is the element of A? Written here A equal to 1, 2, 3. You have to write. Then intersection B union C. You can say here is B union C. B union of C is 2 comma A comma B. 2 comma A comma B. You have to be careful about union and intersection. So here is intersection means only common. So here is 2 and here is 2 is common. You can see here is 2 and here is 2 is common. So you have to write down the answer. So we have got A intersection B union C equal to 2. Equal to 2. Let's come back to another maths. But before starting the maths, you have to be careful about union and intersection. Okay, let's come back another maths. The maths number 2. Here is A. You have to determine A intersection B union B intersection C. Now here is two parts of this maths. Okay, so at first you have to find out A intersection B, then you have to find out B intersection C, then you have to compare last part. Okay, let's come back A intersection B. A is 1, 2, 3. Intersection B is 2 and A. Now, intersection means only common. So here is common is only 2. Common is only 2. So we have got A intersection of B. Now find out B intersection C. B intersection C. Here is A is the common part. So here is we have got A. Okay, we have got A. Now you have to find out A intersection B union B intersection of C. Just for the A intersection B equal to, we have got here is 2, and union B intersection C equal to, we have got A. We have got A. So union means common and uncommon. So we get 2 comma A. This is the answer. So we have learned today union and intersection type maths.